Test, test, test. There we go. Great. All right. It is February 26th, Friday. Oh, test, test, test. There we go. Great. All right. It is February 26th, Friday. Oh, test, test, test. There we go. Great. All right. It is February 26th, Friday. Oh, test, test, test. There we go. Great. All right. It is February 26th, Friday. In-game audio. Check, 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 check. All right. Good morning, everyone. I think we've got audio double broadcasting right now, but the screen behind me should be showing today's class. I'll stop double broadcasting in a second. Can someone confirm in chat that everything's broadcasting okay? Okay, thank you. Single broadcasting on YouTube. Today is Friday, February 26th. And let's see, we're looking in game. So let's run through our checklist to get us started here. I'm managing some windows over here, trying to get everything up and going. I'm broadcasting what my current view in game is. There we go, getting a little better. All right, so let's see, let's go through our checklist to make sure we're ready to run. Find a quiet location, tell your roommates that you're in class and that they need to stop working on their theremin practice. Put on your headphones so that we don't echo when we have a conversation in game. Shut down any extra apps or browser tabs that you have. Let me run through what I've got. I think I shut everything down that I needed shut down. Yep, I'm good. I need to also make sure that my backup processes I have automatic backups that get taken on my computer, and that takes some resources, and so I stop those during class so that it doesn't interfere with my ability to broadcast. So I just stop that. Open Canvas and open Eclipse. I'm connected to Saros right now. Let me, while we run through our checklist and we're doing that, let me go ahead and try and connect the folks that are up so that we can do that while we're running through our checklist. I'm sending some connection notices in Eclipse right now. All right. Eclipse, Saros, make sure you've got your VPN activated so we can use voice if you're on campus in particular. Of course, open Firestorm. If I see you in here, you're already there. Rebake your avatar so everyone can see what you look like in game cleanly. I'm going to do that by going under Avatar, Avatar Health, and Force Appearance Update Rebake. Set the environment so that it is midday, so we're all looking at the same environment. So right now you can see I'm actually set at nighttime because last night I had class and we set it up so it looked like outside. So I'm going to go under World and Environment and Midday, and woo, magically it became daytime. Great, love that. Set your draw distance to a low number if your computer is chugging away and getting hot. So mine is at 192, that's good. Make sure you can see your classmates' names and test your audio. So let me go around and see how we're doing this morning. Good morning, Matthew. See you. Adeline, good morning. Ben, see you rezzing in. Thank you for that. Ethan, good morning. Trent, good morning. Sam. Frank, you've been here for a while. Connected you early before class while I was setting up. Good morning. Thomas, good to see you. Standing up, representing. Good. Ethan, good morning. Faith, good morning. Carson, good morning. See you rezzing in. Ben, good morning. Morgan, taking up position next to Dodger. Good morning. Ben, glowing birds. Love it. Monty, good morning. All right, we got a lot to cover today. Let me come up here to the podium. And all right, let's see. Let's just pray for a sec. If you join me in just a word of prayer. Dear Heavenly Father, thank you for learning. Thank you for Westmont. Thank you for this community of people that we can journey with in our learning as humans, Father, our academic learning, our knowledge. Help us to use that to transform our hearts. Give us the skills so that we can live out your kingdom. Amen. Okay. Let's start by taking a look at the calendar and make sure we're all on the same sheet of music for that. So I'm going to put a calendar down on the screen in front of us. do that by moving windows around. Oops, my window moving was a little slow. Is it gonna work? Okay, we're working. Good. Wow, that's a good start. All right, so today is February 26th. It is Friday. We're going into a weekend because that's how Fridays work. And we're looking to next week. This is the last class we're going to have on Chapter 7, which is the introduction to arrays, two-dimensional arrays, and then the contrast between the way a primitive array works and the array list works. And hopefully today we're going to nail down array list together. Next week on Monday, you've got Chapter 7 Techne due. We'll start working on the next chapter next week on week 8. And then Wednesday, you've got a programming assignment due. This programming assignment is kind of in the shape and scale, I would say, of the pyramid assignment, although the content is very different. And so we're going to take a look at that as we are going through before we're done today. That's an important thing that I want to cover. Okay, good. Questions or comments, logistics from class right now? And if there are none, then what I'm going to do next is let's do a run through on Eclipse and get folks set up that aren't connected yet. All right, so Faith, I see that you're connected, looks clean. I'm going to restrict you to read only. Wow, that happened cleanly. That's amazing. Great. Matthew, restrict to read only. Thomas, restrict to read only. There's a Hello World application up in the files that we're sharing. Looks like Ethan Banez, my side, says that we're waiting for you to accept an invitation, and Monty, same with you. I'm not sure that's accurate on my side. Addie, adding you. Ethan Vaughn, adding you. Oh, Ethan, you look like you're not actually connected to the project yet, so maybe you're stuck in some intermediate world. Same with you, Monty. Morgan, adding you. Sam, adding you. And Trent will add you as well. And then we'll see how that all shakes out. All right, Addie shifting to read only. Morgan shifting to read only. Good. Sam shifting to read only. Ethan Vaughn shifting to read only. This is getting a little smoother for those of you. There are some people for whom this is just very smooth. It's interesting for me to experience this as someone who works on this stuff, and then other people you drop out really easily. I'm not sure what's going on there. All right, Ethan Banez, you're read only and connected. Who else we got? Trent. Looks like you're connected. Good, and read only. All right, we'll do one more pass and then we'll get going. Ben, here you go. Ben Fernberg, Josh Fitzgerald, Landon, and Monty. Do you want me to try you again? Oh, are you in? You might be in. Okay, Ben Fernberg, shifting you to read only. Josh, shifting you to read only. All right, Landon, shifting you to read only. Smooth, Monty, shifting you to read only. Great, smooth, and okay. We'll stick there for the time being. Maybe we'll do another pass in a few minutes. All right, so when we last left off last class, we had a couple classes here that we were working with. We had arrays and array list examples. So let me take that from our last class, copy them, and let me drop them into today's project. And we were looking at an array list and how that might work. Let's just refresh what's happening here. Let's take a look at one particular, let's make sure we're broadcasting okay. Yep, broadcasting code okay. I want to zoom in on that. Okay, good. All right, so if you remember in our main method of our class ArrayList examples, we declared an array using the ArrayList syntax here. The type is capital A, capital L, ArrayList. We Follow that with this angle bracket notation. This is a notation called generics. And what that means is that we have to tell Java what kind of type this class is going to hold. But this type can be composed of both an array list and a type that's in it. So the whole type is array list and the brackets and whatever type we're holding in the array list, in this case integer. What we put in the square brackets has to be an object, has to be a class. And that means that we can't use primitive types there. We can't use lowercase I int, we can't use lowercase d double, we can't use lowercase b boolean. We can use the integer versions, or the object-oriented versions of them, which are generally capital letter versions. We give it a name like data, that's our variable name, and then we allocate it some space by using the new keyword. And what this is doing is this is calling the constructor of the array list that holds integers. So we're constructing a new object, and where data is a reference to it. And you can think of an array list as being an array that is managed for you. So it is an array that has infinite capacity, at least up into what your computer can hold. And you don't really have to worry too much about that capacity because the array list is going to take care of it for you. What that means, though, is at any given moment, you don't know how many elements are in it without checking first to see what its size is. So when we fill an array list here, what we're going to do is we're going to jump up to this method here, and to this method here. And we take two parameters in this method. It is the array list that we want to fill, and it is how many elements we want to put in it. We create a loop using standard loop notation, a for loop, while for int I equals 0, while I is less than how many, I plus plus. And each time through the data, each time through the loop, we add something to the array list. So the key method here is add. What add does is it puts something at the end of our array list, and it has to be something that is of the type that our array list holds, in this case integer. It's going to tack it onto the end. And you can see that we're not managing how big it is, because as we add things to the end, our array list is just going to grow as necessary in order to hold that content. It grows, it grows, it grows. The data is stored in the data variable. The array list holds all the data that we add. In this case, we're adding a sequence of numbers. The numbers that we're adding are the squares of the indices of the elements. So if we start at 0, we're going to put 0, and then 1, and then 2, and then 3, and then 4, and so forth and so on. Now, one subtle difference to what's happening here with our array list than what was happening in the equivalent method that we were using for the array is that when we call the add method, we're putting the data on at the end of our list. If you'll recall, previously we had something that looked like this, where we were putting an element into a specific location in our array. Now that's subtly different, right? If we put data in at a particular position, that's different than putting it at the end of our array. We could put things at the end of our array, and the way we would do that is instead of saying data sub I equals something, we would have said data.length. Now this is only accurate if data is an array. You can see that what that would do would put something at the end. The problem with that is our array only has a certain capacity, and we would run out of capacity and we would have an error in that case. So this is nice because it grows, but it puts things in at the end. Now, what if we didn't want to put things in at the end? What if we wanted to put things in somewhere else? So after we add some elements to our array by calling line 24 fill an array list and putting 3 elements in, well, now we can use 2 particular methods. For example, get, which takes an index, and we could say data.set, which takes an index and then what we want to put in there. Clean that up and assign that to a local variable. Oh, sorry, we didn't go through our full checklist. One of the things that I didn't do is turn off my notifications. So let me do that. And you can do that as well. Okay, so what I'm demonstrating here is the way that we pull individual elements out of an array list. So on line 26, where we call data.get1, what we're asking our managed array list to do is to look into the data that has been placed into our array list and get the element that is at position 1. So the analog to this would be something like calling this if it was a primitive array. It's something like this. A couple things you have to be careful of with an array list is, have you put that much data into your array list? If you call data.get1 and you haven't put two elements into your array list, an element at position 0 and an element at position 1, you're going to get an error, an array out of bounds error, because you've asked to get data from your array list that does not exist. This is similar to what we have on the right if we were to ask for data from position 1 from an array and we hadn't actually initialized it with two elements. Maybe we'd initialized it only with one. We're going to get a similar kind of error. All right, likewise, here at data set 110, this is equivalent to saying data sub 1 equals 10. So assigning the element 10 to position 1. Now you can see that on the left, the ArrayList version is using a very object-oriented way to do this. We're not using special notation like with the square brackets. We're using the standard reference, we're using typical methods, and we're using parameters to methods in order to recreate the effect of an array here. Same thing here. When we set something, we're taking position 1 as a parameter, we're taking the value 10, we're stuffing into it. We're just using a class and a method. No special notations. We're using a very standard way of creating a data structure. There's a way that we expect a array list to work. That's its behavior. That's its contract, and we can look up in the documentation for what happens when we do these different things. A list by nature, and so it is with an array list as well, remembers which elements are put into which slots, and you can put duplicate elements in the same slots. All right, so then finally, after we do a little bit of this work, we fill up our array list, we get a particular element, and let's do something interesting here. So we're going to take this element at position, we're going to fill up your array with 3 elements for starters. So then we know we have 3 elements in it. We're going to get the second element by using index 1. And then let's set the second element. Instead of it being 10, let's double the second element in particular. All right, so we're going to set it equal to twice what it was before. We could do this in one step if we wanted to. We could say something like data.get1 times data.get1. We could put it all into one step if we wanted to, but we'll do it in 2 just for clarity. Put that in a comment. Okay. Great. So now we've updated it. Now it's time to print our array list to the console. What's that going to look like? We're going to come up here to our method that takes in our particular reference to our array list. We know that with an array list, there's not a distinction between how many elements are in our array and what the capacity of the array is. Our array list manages that for us, and so the size of our array is how much data is in it. So we don't need a separate parameter that says how many elements do you care about. We're going to print out our array list data by doing fast enumeration. So this is fast enumeration. Here's one way we can do it. We can say create a variable I, and we use that colon notation to say walk over all of the elements of the data reference. And as you're walking over that data reference, what I want to have happen is each pass through this loop, I want I to be set equal to the next element in the list. So we're going to start at position 1, and I will get assigned the data that's at position 1, and then 2, and then 3, and then 4, all the way up to the end point. That's using fast enumeration. If we wanted to use something that was more aligned with what we've learned so far, we could do something like this. Let me do it outside of comments, and then I'll comment it out so it doesn't mess up our code. We could have said for int index equals 0, while index is less than data.size. Okay, here's another difference with an array list. When you want to know how many elements are in an array list, you call a method called data.size. And then it's a method, so it's got parentheses after it. Remember, if you want to know what the capacity of an array was, you would say data.length. And that isn't a method, it's this weird halfway thing. It's got a dot as if it's an instance variable, but it's giving you something that changes over time based on adding things. So it was hybrid. So in an array, we would have said this. And that doesn't give us how many elements are stored in it. It gives us what the capacity of our array is. ArrayList doesn't have that distinction, so we just say how much data is in there. That's also the capacity. So we'll go through each one of our elements, data.size. Each step, we will increase our index by 1. We will print out not I. We don't have an I. We're going to say data.getIndex. All right. Let's see, and then let's put a new line at the end. Okay, so this is going to do the same thing twice. There are two different ways of accomplishing the same work. Let's go ahead and completely double it. All right, and let's go ahead and run it. What I'm going to do is I'm going to, at the request of one of your classmates, I'm going to run it in debug mode. So I'm putting a check mark, I'm putting a breakpoint after 14, and I'm going to come down to main, and I'm going to say, rather than running it, I'm going to say debug as a Java application, and that's going to kick us over to our debug perspective. Boom, there we are. You can't see it, so I'm going to unzoom the code. Whoop, there we are, unzoom the code. My face is covering, on the broadcast, my face is covering the outline, which is just showing us the different methods that I'm looking at. But on the left, what we can see is that we have run our program and we have stopped at line 14, which means we've already filled our array. We've already gone through the main method up until the point at which we're calling print ArrayList to console. So a couple different things I can look at over here in my expressions. I have some expressions that were left over from a previous debug session. So I'm going to clear those all by hitting the two X's on the tab bar. Remove all those expressions. I can see in variables, I have access to all the different kinds of data that's available to me in this scope at line 14. If I open up data, I can see that there's a bunch of the implementation of my array list becomes clear to me or becomes exposed to me as a debugger, as a developer, and I can look into some of these elements here. So you can see that data actually has 3 elements in it, and the first element is 0, and then 1, and then 4, because we're done, we just finished filling it up. Over on the left here, you can see what is running. You can see that I have a project and that I'm running it. There is one thread in this program. This is a single-threaded program. Multi-threaded programs is an advanced topic. And you can see that within this particular thread, I am running the main method first. My main method, as I clicked on that, I jumped to where I was in the main method, line 35. And then if I click on the element above it, I'm looking at the stack. And so I'm looking at let's look into the function that was called on line 35 and see where we are in that function. So line 35 called this method, print ArrayList to console, and we are currently at line 14. And now I'm going to step over, let me find my correct icon at the top. I'm going to step over line 14. You'll see on the console we printed out ArrayList data. And now I'm going to step through my loop. Each time I go through my loop, I will take on a different value. I is an integer that is declared within the scope of the loop. So if we look up here right now, there's no I variable that's currently defined in our variable. But if I step over this line and I'm in my loop, suddenly an I variable shows up because now there is an I variable in the scope of execution. It has the value of 0 because the first element in my array list is 0. I'm going to step over line 16, print it out. Now I go back to the top of my loop and I is gone. Now I'm going to instantiate I with the next element in data. I can open this up and see the next element is 1. The value of the next element in my array list is 1. I'm going to print that out. Go to the top. I has been garbage collected. It is no longer present because I'm starting a new pass through the scope of my loop. I will create a new variable I, and it will be set equal to the third variable, the third value in my array list, which is 4. Now I'm going to print that out. Boom. I have now reached the end of my array list, so line 15 will have no more data. And so we'll be done with my list, having examined each element in my array list, and now I'll print out a new line character so that my console will start outputting to the next line. You don't see anything in that process, but the cursor has advanced. Now I will do the same work, but I will do it with a different kind of loop, a for loop. I'm going to print out array list data, and we're going to go through the same array list. The data hasn't gone away, it's still present. Instead of using fast enumeration like I did in line 15, I'm going to manually step through the data. I mean, sort of manually. I guess it's manually. And what that means is I'm going to take charge of the indexes, and I am going to pass all the indexes over the data. And to do that, I have to set up a for loop, and I'm going to create a variable called index. And I'm going to walk through each of the elements in data one at a time using the index, and then using that index, 0, 1, and 2, to look up the data in the array list. You can see that all this work was done for me automatically in fast enumeration. But in loop on line 21, I'm going to do it manually-ish. All right, so index shows up here. Index starts out at 0. I need to look into my array list at position 0 to see what the data is. Step over that, and we'll print out a 0. Now I go to the top of my for loop. Index hasn't gone away because it is something that is constant throughout the entire body of the for loop. But as I step over this line, Index will be advanced to 1. You can see it turns yellow in the upper right to indicate there was a change since the last line I executed. I will now print out what is in position 1 because I'm going to use 1 as the index. I'm going to print that out, step over it. The index, position 1, and the data stored in ArrayList were the same. Now I'm going to advanced index. It grows to 2. My index is 2, but as I look up what's stored in position 2, what's stored in position 2 isn't the value 2, it's the value 4. So I'm going to output 4. I've then reached the end of data, or index is now equal to data.size, so I don't meet the conditions for running this for loop. I will step over this now. I'll print out a new line character, which won't be visible, but will advance my console cursor to the next line. And now I will return from print array to console. This method is done. And up here, we will see that the stack, this line that's highlighted blue, will disappear because this function call is done, and I'm going to return to main line 35 where I was before. So this is my current line of execution. I step over this line. I'm now returning to line 35 and then stepping to line 37. My program is done, and so I run. So I'm done running. All right. I guess we didn't really get to see, because 1 times 1 is 1, we didn't really get to see this work. So let's change this to getting position 2 and then changing position 2 instead. So what you can see is that originally, before I made this change on 31 and 32, we outputted 0, 1, and 4 twice. What I hope to see now is we'll output 0, 1, and 16 twice, because both times it's being printed out from this call. I'm going to run it as, I'm going to go back to my Java perspective by coming up here to the upper right and finding the little J here. I'm in my debug perspective here. Now I'm going to switch to my Java perspective. If I ever want to find a different perspective, I can click here and see a long list of perspectives that are available to me. A perspective is just a layout of panels in my Eclipse window that is appropriate for different tasks I might be doing. My general programming task is done well in my Java perspective. I'm coming back here because I want to run my main method and I just want to run it. I'm not going to debug it this time. So even though I still have a breakpoint up here, the breakpoint is going to be ignored because when I execute the main method, I'm running it. I'm not debugging it. So I'm going to run it as a Java application. Save my changes. Go to my console, and now you can see that 16 is being output because of the way I interacted with my array list. Pause for a second and see if you all have any questions about this code. Give you a moment to consider it and see if you've got anything. All right, let's look at a few slides. So we've looked at a lot of code to examine this. Let me go ahead and invite folks who haven't connected yet on Saros. Let's give it a shot. What I'm going to do is, you can look at the code if you can get it from Saros. And what I'm going to do is switch over to a slide deck so that we can look at this in kind of an academic format and see if that helps us to learn a little bit more about array lists and array algorithms. When we're done with this, I'm still interested in answering any questions you have, especially about comparing the two. But then we will shift gears and talk about the homework assignment. All right. Let me just check, make sure we've got no comments or questions in the text. Looks good. Good morning, Matthew. All right. All right, looks like Carson came in, restricting you to read only. Looks like the rest of you are having some sort of trouble, so I'd recommend trying to restart Eclipse, and if we get a chance, we'll share the project again with you. All right, shifting over to a slide deck. Whoa, just trying to shift over to slide deck. Breathing deeply while we wait for my computer to catch up. Great, there we go. All right, so we want to be able to do those same kinds of algorithms that we looked at when we were talking about our array lists. Your textbook goes through a whole set of really valuable template algorithms that one often runs within an array. That is important to get your head around because when you run these algorithms, I mean, like a lot of the work that you do with arrays are variations on these very basic template algorithms put together in the correct way with the appropriate data. So being familiar with how to do those things is really important, and that's going to be important to build on going forward. As we think about those kinds of arrays, as those kinds of algorithms, for example, finding the sum of the elements in an array, searching to see if your array contains a particular element, inserting an element into an array or an array list, finding the average of elements in an array, swapping elements in an array, swapping the first element and the last element of an array, finding the maximum or the minimum of an array. These are all algorithms that you should be comfortable implementing because you're going to need them in order to build the kinds of things that you want to build. All right, so just to run through this, our array algorithms, they can be converted to array lists by using the array list methods instead of the array syntax. And that's like 80% true. There is a slightly different way in which you think about an array and you think about an array list because of the fact that the array list is like a machine. The array list is like a machine that's managing your data for you. And the array list is like a chunk of memory that you've got to manage yourself. So the object-oriented version is doing a lot of work to help you manage capacity, and the array, you have to do it yourself. So there's a slightly different way in which you think about it, but there is a corresponding set of methods that work between both of them. So here's an example to find the largest element in an array, the first yellow box that we're presenting here. We start by assuming that the largest element is the first element in our array. So again, the first case, we're looking at a primitive array. Values contains doubles. We assume that the very first element, value sub-0, is our largest element, and then we're going to look and we're going to correct that assumption by doing a loop. Now we go through our loop and notice that our index starts at position 1 because we've already considered position 0 in the initialization of our largest variable. We're going to go from position 1 all the way up to position values.length. Because of the way zero indexing works, we won't look at that particular element. We'll look at values.length minus 1 as our last element. For loop, incrementing I each time at the end of our loop. The first time we pass through our loop, I is going to equal to 1, and we're going to check to see if the current element that we're looking at in our array, the current element is being kept track of by I, the index. If the current element we're looking at is greater than the largest thing we've seen so far, starting at position 0, then we're going to change our mind. And we're going to say, hey, no, it turns out that the largest thing we've seen so far is actually now value sub I. And we're going to keep track of that value in largest. So at any given point, as we go through this array, we know that the variable largest is going to be the largest element in our array up to the point that we have considered so far. 0 when we drop into our array, and then we update that one by one as we go through each element of our array. So by the time that we're done looking at every element in our values array, we have considered every element, we've considered it against the largest that we've seen so far, and so when we get to the end of our array, we know that we have the largest from our entire array. That's an interesting algorithm, I think. We can also do that with an array list, and that's demonstrated in the second yellow box, the object-oriented version. In this case, we assume that values is an array list filled with doubles, capital D double. You can see that when we say values.getZero, we're asking what is the double at the position 0 in our array list. We're going to store that in the variable largest, and you can see here that we're transforming our capital D double, which is returned by get, into a primitive double D. Java does that very naturally through a process called boxing and unboxing, and so that's a support that Java gives you for transferring between the object-oriented version of primitive types and the primitive types. Same thing, largest starts out with the largest element in our array list up to the point that we've considered, which is just the first point, position 0. If our array list only has one element in it, then we're done because largest is the largest because there's only one element in it. But if there are more than one thing in our array list, then we're going to go through it in a loop. And so we do that in this for loop. And you can see that instead of values.length, we use values.size, which is a proper method. We'll continue incrementing I each time through our loop. And instead of using the square bracket notation, we'll use the get notation to look at what the largest element is so far. evaluate whether our current new element that we're looking at is larger than the largest element we've seen so far. If the current element that we're looking at is largest, we'll update what the largest is so far, and then we'll continue through our loop. So that, just like in the array, when we get to the end of our array, we've considered every element. We've considered every element against all the elements before it, and if the current element is larger, we have now kept track of the largest element in the array overall. Any questions or comments, any concerns about this translation between array and array list or this algorithm? I'll just give a pause for the latency to catch up. Okay, nothing so far. Great. Storing input values in an array. We kind of saw this in our Eclipse work, but one thing that's nice about our array list is if we don't know how many elements we're collecting, we don't have to worry about the capacity. And so in that way, array lists are easier to use than arrays, at least in that way. Here's an example of how we might do that, assuming that we have a scanner that has been initialized and that is stored with a reference named in. So we'll just keep reading those elements in and adding them up. So in our first line, we create an array list that's going to contain doubles, capital D doubles. We do that with array list and then the square brackets. And so inputs is our variable name. We have a reference. Our reference will be pointing to null unless we actually allocate an object for that. To create an object, we call the new reserved word, and then we call the constructor. Notice that on the right side of in this position here, notice that we're using two parentheses because we're calling a constructor. And so we have to put the new word to say we're calling the constructor, the type whose constructor we're calling, and then whatever parameters that constructor requires. If it requires none, we still need to call it as a method. Then we call a while loop. We use the look ahead, has next double, which is going to look to check to see whether what the user has typed in is going to get parsed correctly as a double. And if it is, then we know that a double is available on our scanner checkout line, just like at a grocery store, in which case we will grab that next double here, and in.nextDouble will be evaluated to the next double that the user has typed in the console, and we will immediately translate their characters into a double, and we will add that to the end of our array list. And so with this 4 lines of code, 2 lines of substantial code, we can read in as many doubles as the user wants to enter in, and when the user enters a Q or something else, because that does not parse as a next double and has next double will return false, we'll exit our loop. So this is a very clean way of reading in an arbitrary amount of data from the user. The only thing that I would say is missing is some compassion for the user who has no idea what you're asking them to do. So what's missing from this are some prompts explaining to the user what you're expecting and also explaining to them how they quit the loop that they're in. But the core elements are here. All right, here's an algorithm for going through an array list and removing matches. So let's say there's a certain kind of condition that we want to remove from our list. So first of all, we're going to initialize a new variable called words. Words is going to be an array list filled with strings. And these dots here represent some process for capturing an array list of strings. Maybe we read them in from a user by calling a method. Maybe we use a literal to enter them in. But the point here is not that ... is valid syntax. ... is a placeholder for teaching purposes that says that in some way I'm going to initialize my reference words with an array list filled with strings. And then my goal here in this code is to get rid of all of the words that are smaller than 4 characters long. So all the short words. Maybe this reads in a story and it gets rid of all the short words. So I'm going to do that explicitly by going through and creating an index variable that walks through the entire length of my array list, starting at position 0 and ending at the position which is equivalent to the size of my array list. Then I have to pull the word out of my array list because I'm using manual indexing. So I have to get the element at position I, store it in a local variable so that I can evaluate it. I'm evaluating it here and says, well, if this word meets the condition that I'm trying to look for in order to take things out of my array list of words, then I'm going to remove the element at index I. Okay, so if it meets the conditions, I'm going to remove the element at index I. Now we have to be a little bit careful here because when we remove the element at index I, everything shifts to the left one. And if we were to just do our for loop without any modification, you can imagine that if you have, you're looking at position 0, which is the first position in your array list. Position 0 has a word that's short, and so we remove it, which causes everything higher than it to be shifted down. And then we go to the end of our for loop and we add 1 to I. So now we're looking at position 1. A piece of data that was at position 1 got moved backward, and we didn't actually evaluate it because it got shifted back into position 0, and we only checked position 0 once, not again after we shifted everything to the left when we removed it. So here's an example of a bunch of words that we might have. It's a little bit small. I apologize for that. Let's see if we can zoom in a little bit. So the words might be welcome to the island, and what we're trying to do is get rid of to and the. And as we go through position 0, welcome doesn't meet the requirement, so we keep going. We go to position 1 and we remove the word to, and the island shifts to the left. And now if we were to arbitrarily look at position 2, welcome is 0, the is 2, the is 1, island is 2, you can see that we never examined the word the because it kind of slid underneath our radar as we removed stuff and advanced our index. So we have to be careful that we don't increment I in this case when the element is removed. We need to double check it. So what we can do is we can counteract that. Here's pseudocode for it. If the element at index I matches the condition we're looking for, we want to remove the element. Otherwise, we want to increment I. So we're going to have to play around with our loop a little bit to get the effect that we want here. Here's an example of how we could do it. We could use a while loop instead of the for loop construction, and this will help us to manage our index the way we want. We'll initialize an index I equal to 0. Previously, this was done in the syntax of the for loop, but now we're shifting kind of backwards to a more primitive, a less structured way of doing a loop, which is the while loop. I is still our index. Our condition is still the same, while I is less than words.size. But we're going to take control of that incrementing of our index. And in the body, it looks very similar. So we're going to get the word that's at position I. If it meets our condition for removal, in this case, our condition is that the length of that word is less than 4 characters, then we're going to remove it from our data structure. Word is not the same as words. Words is our array list, and word is the current one that we're looking at. So the fact that these have an S and no S, one's plural and one's not, makes a difference. From words, we're going to remove the element at position I. And if we did remove the element at position I, we're not going to advance I. We're not going to go through this else step. We're going to go immediately back up and check to see whether I is less than word size. And if it is, then we're just going to look at the same position again. The same position again, because as we slid stuff down, a new word got moved into the same position. If it turns out that our word does not meet the condition, well, then nothing slid down, and we will go ahead and go to the next element. So this is an example of something where putting it on paper, hand walking through the loop, and looking specifically, maybe using the debugger and stepping through the debugger one at a time, looking at how your variables and how your data structures are changing as you go through the loop, will give you a lot of insight into how the code is operating. All right, let's talk about choosing between array lists and arrays, and then we'll take questions, and then we'll shift gears into looking at the homework for this coming for week 8, which is about chapter 7. Okay, when you want to choose between an array list and an array, you have to have thought a little bit about your task at hand, and you have to understand a little bit about the difference between arrays and array lists. Certainly for the first well, I don't know. It's hard for me to say that, gosh, it's a design question, right? At the end of the day, this is a design question. And when you are acting as a designer, you must understand your materials. It doesn't matter whether you're Apple and you're designing a new iPhone, or whether you're a software engineer and you're designing an algorithm, or whether you're a fashion designer and you're designing a new dress or a new outfit. In all of these cases, you have to understand your materials and you have to understand your vision and you have to understand how your materials and your tools work in order to best reach your vision that you've got. And like saying whether you're going to use an array list or an array, which one you're going to use most of the time is like saying, well, what material are you going to make your dress out of? Well, I don't know. You're going to make your dress out of like polyester or something, or nylon or cotton. I don't know. What do you make your dress out of most of the time? It depends on what kind of dress you want, right? So the same thing, choosing between an array list and an array is a question about which tools you have. I'm going to say mostly you're going to be safe going with an array list. And that's like saying you're going to be safe making a cotton polyester blend dress. I don't actually know if that's true. It seems like it's true. I'm not a fashion designer, but I would. Okay, I need to get out of that space. Okay, so most of the time you're going to use an array list. They're easier to use than arrays. There's less overhead. They can grow and shrink as needed. They have a slightly nicer syntax because they conform to object-oriented syntax. They're consistent in that way. They don't have special syntax of dot length and square brackets. Um, However, if you know that you're going to work with a collection of data where the size never changes, like you're never going to go above a certain size, well, that's a good indication that maybe what you should be using is an array, because one of the big advantages of your array list is that it manages size growth and shrinking for you. An array is slightly faster. The work of being an object-oriented data structure takes a little bit of time for your CPU, and so an array is going to be a little bit faster. So these are all, a design question. You're probably safest using an array list at this point in your career, but you have to know why you're choosing that, because there will be times when there's a better choice at hand. In particular, this concern about efficiency. If you have a collection that never changes, you have a very long sequence of primitive types, and you're concerned about efficiency, that's the giveaway. Like if you're concerned about efficiency at really high performance computing, then you're going to lean more towards an array because it's just closer to the metal and it's a little bit faster. Okay. Just kind of a rundown of very specific translations. If you want to get an element, in arrays you use the square bracket notation. In array lists you use the get notation. If you want to replace or set an element, in the array you use the square brackets on the left-hand side of the assignment, and in an array list you use set. Now you have to be careful that you have memory set aside for 5 positions, but if you do, then this will work. To find out how many elements are present, you use values.length in an array, and you call a method, values.size with parentheses in an array list. To figure out how many elements you have in your data structure, well, you have to use your companion variable. Maybe it's called current size for an array. Whereas array list, it's the same thing, values.size. There's no difference between capacity and how many elements are in your array list. To remove an element, take a look at the algorithm in section 7.36 for how to shift things down in an array, especially if you have a current size variable. In an array list, you just call remove, and you remove the element that you want. And the mechanics and the mechanism and the machinery of array list repair the state of your data structure. It does the work that the algorithm in 7.3.6 does automatically for you. That's kind of why you like the array list, why one might like the array list. If you want to add an element to the growing collection, well, that's a little bit of work. See 7.3.7 for how to insert something into an array. Otherwise, in an array list, you just add it at the position that you're interested in. This is added at the end. So this will put 35 at the end of your array list. To initialize your connection, you can use a literal in an array, but in an array list, there isn't any kind of literal for your array list. You have to write a method that will put elements in it by calling add 3 times. So, here are some trade-offs. What are you going to be doing? Okay, we looked at a bunch of examples. Let's see if there's anything else I want to say about array lists. I think that's it. Okay. So what I want to do now then is I want to shift gears and I want to talk about our homework assignment for next Wednesday. And let's do that by pulling it up in Canvas. Let me see if I've got it handy. Not super handy, but I can get it here. Window management. Okay, 7, here we are. All right, so you all may be familiar with the way in which former President Trump's tenure was dominated by communication through Twitter. Uh, he used it as a primary mechanism for for communicating the messages that he wanted to communicate, reaching his base, but also reaching the rest of the world. Caused Twitter to be the source of a lot of media attention as a result. So what we're going to do for this assignment is we're going to write a program that can automatically monitor Twitter feeds for us. What it will do is it will run and it will go out and get an individual's Twitter feed, and we're going to use it to search for particular things that we might be interested in. Like, for example, maybe you are someone who is interested in monitoring to see if there's any update to the cost of college. One of the policy proposals that's being discussed is making community college free, for example. Maybe that's something that's interested to you, and you would like to have something that monitors uh, tweets from the president about community college. And so this is a program that could do that. So we're going to write that. There's a couple things that you have to have in place in order to make that happen. You have to have a Twitter account. So let's start there and make sure that if you do not have a Twitter account, you do need to set one up for this assignment. And you might want to do that immediately so that you don't get caught in any sort of like delay while you have to, I don't know, get approval or something. This is what it looks like when you're in Twitter. Down here at the bottom right is the account that you're currently signed in as. So I have a Twitter account. I have irreverent and provocative therapy tweets. My Twitter account is DJP3, and that's something that is out there. You follow people on Twitter, and that then creates this news feed where, in chronological order, everyone who you have chosen to follow, if they ever tweet, it shows up in chronological order. It's At least you can set it up that way. It's a little different from Facebook, if you even know what Facebook is like. It's a little bit different than Facebook because Facebook shuffles everything and tries to put things that it thinks is most interesting to you at the top. Of course, Facebook gets in trouble for that because what they're balancing is things that they think are most interesting to you against things that are going to bring them the most money as well. Twitter, a little less aggressive in that regard. It just shows you a chronological feed. I think there's a setting where it can choose for you, but I have that turned off because I don't want algorithms telling me what to look at. So I get this update of everyone who I follow who has tweeted. Interspersed with this are occasional ads. So for example, here is an ad for Solar Opposites on Hulu, which I guess is a show. And you can tell it's an ad because down here at the bottom it says promoted, and that tells you that it's an ad. Over on the left are a bunch of navigation things for direct messages and different kinds of notifications you can get. Over on the right are, what's trending and suggestions on who to follow. Down here is a quick link into my direct messages if I want to look at that. Scroll down, it's got infinite scrolling, so you can look at your news feed. Your news feed is one particular view, but another view that you can look at is an individual's view. And if you look at a particular individual, so this is a friend of mine who works, who's a Westmont alum who works down as a software developer at the University of California. You can go to his particular page, and down here in tweets, you can see the list of all of the things that he has tweeted, meaning all of the messages that he has written and posted, and also anything that he has shared. So anything that he has liked and he has added to his particular newsfeed, which then goes into the newsfeed of everyone that follows him. What we're going to be doing is we're going to be looking at one individual's newsfeed. So for example, if you go to POTUS, which stands for President of the United States, you can look at what President Biden or his staff wants to put out on this feed. And you can see that, for example, this first post right here is, if there is one message that needs to cut through, it's this: the vaccines are safe and effective. Be a little bit careful because it's possible to pin a tweet to the top of your feed so that if there's one tweet that you don't want to be pushed out of the way by new tweets, you can pin them at the top, and to actually see the tweets in timeline, you have to scroll before it. So I want you to note that because we're going to look at that in this. Okay, that's just the tweet in particular. I'm going to go back to his feed. If there is one message that needs to cut through, it's this: the vaccines are safe and effective. Okay, that's his most recent tweet 9 minutes ago. To write our software that's going to be able to process these automatically for us, we need to have an account on Twitter, and then we need to create a developer account on Twitter. Developer accounts for Twitter are at dev.twitter.com. And this is in the Canvas discussion of the assignment. Whole other different interface for Twitter. This is for people who want to write programs that interact with Twitter. So this is my developer situation. My account is logged in up here. I've got my little gear symbol there. What you want to do is you want to click into the developer portal, and you get a little dashboard of all the applications you have authorized to work on your behalf through Twitter. You want to go under projects and apps, and you want to click on, well, I guess if you've got it already, what you want to do is you want to create a new project and give your project a name. A project is a collection of apps. I don't know why they use this, but what we'll say is this is for me, I'm going to say demo for CS-030. Hit next. What best describes you? What's our use case? I'm going to come down here and I'm going to say, oh, I'm a student. That's how I'm using this. What's my project description? Well, let's see. What I'm going to use is I'm going to use some text that Professor Patterson wrote for me to explain what's happening. That's in the Canvas assignment. I'm going to put it in here and we can read it and make sure you agree with it because it's on you, not on me. You need to make sure that this represents you. It says I'm using the Twitter API, the application programming interface, as a programming assignment for my class. It will teach me how to use a web-based API and Twitter's API in particular. This particular project that I'm asking, I'm asked to complete is to retrieve all the tweets of a politician of my choice and screen it for keywords that I will provide. The end result is a list of tweets that politicians have authored that contain the keyword. There's no active tweeting that's part of this assignment. What that means is that my application will not write tweets for me. Neither is there any retweeting. So my application will not retweet these tweets. That's what bots do. If you've heard about Russian bots, what we're doing is we're writing a bot like a Russian bot. Only our bots are not going to actively write content. We're not going to actively create disinformation. We're just going to work as a monitor for one particular feed. We could write a bot that actively promoted disinformation, and join me in senior seminar when we talk about ethics. I'll be displaying Twitter content, but not online, just in the console of the computer that's running the application. It will be individual tweets. This particular application is going to be the reference application to demonstrate the approach. So that's for me, not for you. So edit it so it makes sense because it's likely that someone at Twitter will reference this if there's a problem. Okay, hit next, and now you choose an application that you want. I'm going to create a new application. I'm going to call it Politico Tweet. I just made that up. Can you believe it? Can you believe I made that up? All right, then I'm going to hit complete. And here are some particular passwords that are now being presented to you. These are passwords that you need to remember because you're going to need them in order for your program to be able to get information from Twitter. All right, so let's go over to Eclipse. Boom. All right, here's my reference. Here's my old. All right, let's go to Canvas. I lied. Let's go to Canvas. I'm not showing Canvas. Where'd Canvas go? Here's Canvas. So I'm going to Canvas. I'm going to download the project. Stand by. Let's just click download. Hope it speeds up. All right, now I'm going to go through the process of importing it into Eclipse. So in Eclipse, I'm going to go under File, Import. I'm going to go under Projects from Folder or Archive under General. Hit Next. I'm going to select Archive over on the right. I'm going to navigate to the file that I just downloaded. I'm going to hit Open. I'm going to see that there are a couple options here. All I want is the project that's called Episteme 7. So I'm unchecking that first box and I'm going to hit Finish. And now Episteme 7 shows up over here on the right. It will It will have some errors in it because the code that I'm giving you is not complete. You see that it is a Maven project. So just to get going, I'm going to hit right click on this. I'm going to go down to Maven and I'm going to do update project. And what that's going to do is it's going to go out to the internet and it's going to download the library that we're going to make method calls against that will do our request to Twitter for us. It's a library called Twitter for J or Twitter for Java. All right, let me close out our particular examples. I'm not sharing this project on Saros intentionally. You can look at it yourself, but you can reference the YouTube video if you need to back up. The source code for this project is stored under a directory source main Java, and then we have our package name, and political Twitter is here. The first thing that you notice at the top of political Twitter are there are some constants in this class. This is the class that you're going to work with. The constants correspond to the passwords that Twitter is giving you when you set up your developer account. You only get to see those passwords one time. Once you go past the screen that Twitter displays your passwords on, you can't see them anymore. Twitter won't show them anymore for security reasons. So you must copy them into whatever context you want. And if in the future you need to get them back again, you're going to have to recreate a new application. So going back to my developer account, I'm going to get my API key. I'm going to copy it, and I'm going to go back to Eclipse, and I'm going to paste it in. Now this is a secret key, and so the fact that I'm putting this on YouTube is a real problem, because if at some point in the future someone was to watch this YouTube video, take these characters, put them into their own program, they would then be able to use my credentials to write a Twitter bot. So some Russian bot could write some Russian malware, doesn't have to be Russian, some like, I don't know, Washington, D.C. malware could be using my credentials in order to write a Twitter bot that is attached to my identity. So it's important to me that these passwords not leak out into the world. And so after I'm done with this demo, I'm going to delete my application so it doesn't work anymore. All right, the other thing I need is my API secret key, and I'm going to drop that into the code here. Great, they're both strings. And then this bearer token, I actually don't know what to use this for. I'm not sure what it's used for generally, so I don't even know what to do with it. So I'm just going to leave it there and ignore it and lose track of it forever. I'm going to hit app settings now. And in my app settings, this is sort of a dashboard for how my app is working. I need to go down here and hit this key button to get keys. This first set of passwords for me as a developer. Now I'm getting a set of passwords for this application that I'm making as this developer. I'm going to go under consumer keys and I'm going to regenerate them. Oh no, wait, I don't want to regenerate them. That's what I just made. I want to make my access token and secret. I want to generate those for the first time. Copy my access token, drop it in here, clean it up, boop, boop. All right, good. Make sure there's no extra space in there because that space is part of the password. I don't want that. Make sure there's no new line character at the end. Make sure you copy it exactly, because if you don't get it exact, it's not going to match the password. I copied the second one, the access token secret. We're using a kind of authentication called OAuth 2, if you follow along with any of that technology. This is OAuth 2 from a programming interface. Click yes, I saved them. Now I've got my dashboard if I want to look at how it's being used. Okay, meanwhile, back in Eclipse, I now have my passwords in place, and I now have to put a Twitter handle in here for the skeleton code for the account that I want to follow. So I'm going to do @POTUS. So that's the Twitter account. Twitter accounts start with an @ symbol. So I'll do @Twitter, @POTUS, and then my main method. Let's walk through how this works. Configuration Builder is something that's provided by Twitter4j, and if I highlight over that, I can see that the package name reflects the fact that it's coming from Twitter4j, something that I imported both at the top of my file, but also as part of Maven, I got the code. You can see the Java doc is written there that describes what this particular class does. I'm calling the constructor on it and storing a reference to it here. Configuration Builder is a way that we set up our settings for our application. So I'm going to go ahead and turn on debug in my configuration builder by passing it true. I'm going to set my passwords according to the constants that I set up above. That's part of my configuration builder. Twitter4j now has a new class, which is called the Twitter Factory. And Twitter Factory takes as an input the configuration builder output. So I have to call the build method on my configuration builder. I pass the result of that to my Twitter Factory. I now have a Twitter Factory that I can use to make Twitter connections. Store that in a reference called TF. The type is Twitter Factory. Do I know much about how this works? No, because of the principle of abstraction and encapsulation. I want to use it. Do I know how it's implemented? Nope. I'm using it as an API programmer. All right, so now I take my Twitter Factory and I call a method which is called getInstance. And getInstance will return an object called Twitter, provided by Twitter4j. And this is an object that then allows me to make connections to Twitter on behalf of my developer and application account. I'm going to now use what we do know. We know how to make an array list. My array list will be a list of things called status, a class provided by Twitter4J. I don't know exactly how status works, but what status is it's a tweet. Every tweet is represented by Twitter4J as a status object. So I'm going to create a list of tweets here. That list I'm going to store here, and list is a parent class of ArrayList. I apologize. I probably should have called that ArrayList to reduce confusion, but I didn't. All right, the variable is called statuses, and now I'm going to go through the process of going out and requesting those from Twitter. Twitter4J gets them in pages, and so I'm going to get the first 100 tweets from the POTUS account. I ask for a page of tweets indicating what index I want to start with, what index I want to end with, and you notice that this is not zero indexed. I'm sorry, I did that quite wrong. When I hovered over this, I realized that I described that wrong. Instead, what these numbers mean is I want the first page of tweets where each page contains 100 tweets on them. So this is going to give me one big chunk of tweets. So we have this page object, and now I'm going to put all those tweets that I got into the array list that I understand by calling twitter.getUserTimeline, the Twitter handle I care about, the size of the page, and what this method is going to do is go out to the internet and return an array list of statuses. If something goes wrong, there will be an exception thrown. I will print that out, and then my program will crash. If it doesn't, then down here is where you're going to do the work of the assignment. There are a bunch of things I ask you to do about filtering for particular keywords. But what I'm going to do just for demonstration is I'm going to use the method that we understand here, which is get. I want to get the tweet at position 0. That will return an element of type status. Status has a bunch of methods that I can examine. I can get when it was tweeted. I can get what location it was tweeted at. I can get the language it was written in. I can get a quote of what the status was. I can ask how many times it was retweeted. I can get the text of the tweet itself. I can get the name of the user that tweeted it. All kinds of stuff that's associated with the numerics in Twitter. What I care about immediately is just to get the name of the person who tweeted it. So I'm going to pull it out using a sequence of method calls. I'm going to concatenate that with a colon, and then I'm going to get the text of the tweet. And together, when I run that now, hopefully everything will work okay. Right-click on main, run as a Java application, save everything. Down here in my console, I wait to see what happens. There was a pause while it made the network connection, and you can see that President Biden tweeted, if there is one message that needs to cut through, it's this: the vaccines are safe and effective. And then here's a reference to the picture that is associated with the tweet. So what I have now and what I've demonstrated for you is how in programming assignment number 7, you are able to use the Twitter API to programmatically go out and collect an array list of tweets. Again, array list is what this chapter is about, so that you can go through and do the kinds of algorithms that are written about in chapter 7 to examine the array list of tweets that you have. And in particular, in this assignment, I'm asking you to ask the user for a keyword. The person who's running your program will type in the keyword, will type in a Twitter account, and then your program will go out to Twitter, get the list of tweets from that particular individual that the user of your program has entered in, and will filter them out and only show the ones that contain that keyword. All right. I've got a couple minutes for questions if anyone has any questions, but remember that this will be archived if you want to go back and look through the procedure again. That's actually a nice aspect of recording it on YouTube. Yay, hooray. YouTube, human flourishing in this case. Questions and comments. I'm going to switch to game audio. Okay, that was a good question. Just to summarize for the purposes of the recording, what the question was, the question was generally, should my final assignment do some work to ask the user of my program what Twitter feed to follow and what keyword to pull out? The answer is yes. And in order to do that, you may need to modify some of the final, you may need to remove the final modifiers from some of the variables in the skeleton code. The other question was, does this code successfully go out and get a collection of statuses from Twitter? It does. So most of the work is just manipulating. I guess the work is getting input from the user, executing the code that's present to get the selection of statuses, and then working with the array list of status to do the work that is relevant to sort of the chapter 7 work that we're interested in. Okay. If there are no other questions, then great. Thank you for your attention. Have a good weekend. It looks like it's going to be pretty good weather. Um, if you have any questions, let me know on Slack's a good place or office hours. Have a good weekend. Take care. That's okay. You're welcome. Set Dodger free. Ah, come on, Dodger. Why aren't you walking around? Yes. Hmm, I don't know. Okay. About 7. All right, double broadcasting, single broadcasting. Okay, this is the end of February 2nd, sorry, February 26th, Friday. We finished up chapter 7. We looked at programming assignment number 7, which was the process of writing a Twitter bot. All right, wrapping up. We'll go out with some music from Ketsa called Up Fronts.